Okay. Hmm. Today we'll be discussing the third lab program. That is creation of your predictive parser. Yes, we have created the parsers in the class, which using a context-free grammar, then checking for these ambiguities, and after that finding the first and follow set, and then we constructed the parser. And also we have seen the YAP tool so as to construct the parsers. So this much we have. But the program number 3 is asking us to implement a predictive parser. For the grammar, you can see on the screen, the grammar given is this. A produces A, B, A, B produces B, B, and B produces at the rate. Here we are considering this at the rate as a epsilon. That's what is our epsilon. So if we look at the grammar, the minimal string, what we are supposed to get is A, right? Two A's, not a single A, because A, B, A. If B is epsilon, obviously the minimal string what we may need to get is A. That's what is a minimal string. So we can have any combination of the string that starts with A, ends with A, and any number of B's in between. There is 0 or more B's you can have, right? Even A will work on, right? Any number of B's, A will work. All these possibilities will work. So now we are supposed to implement the parser means we are supposed to find the first and follow. We are supposed to find the what we call we are supposed to construct the parse table. Then we are supposed to parse the string. But our intention is that when we give an input, we should construct the means it should show the parsing, that is using the stack, input as well as the action. So it should start from the start state and should be able to obtain the entire string. That it should show how it can do it by using the stack as well as the input string. So for that reason, so as to simplify, if you look at the other manuals of the same program, the program runs for 3 to 4 pages. And I am telling you, this is not a Lex or YAP program, but it is a C program, simple C program what we are writing, so as to show the parsing of the string. So and how we have simplified, I'll tell you that. First thing is we have what do you call uh, yeah. First thing is that the grammar is given in the lab question clearly that this is the grammar. The grammar is not changing. Many others have created a what do you call program which can work for any grammar. That's not our purpose. Our purpose is to solve only the grammar, whatever is given in our lab question. So keeping that in mind, we can easily find the first and follow because A produces A, B, A. Obviously, the first of A is A. B produces B, B, or B produces epsilon. So obviously, the first of B is B and epsilon. Similarly, the follow also can be easily found, right? So for that reason, we are not computing the follow and first in the program, but we have pre-calculated it and used it and constructed the parse table. Got the idea? So only the parsing of this given string, input string from the user will going to be seeing or will be processing in our program. Getting the idea? We are not finding the first and follow, not computing the parse table in the program, but we do it manually, means which we have did already and have used hard coded those values in our program. That is not again will be calculated. So that's the point number 1. We are just parsing the string. First, I'll show you the output of this particular thing. Then we can see the program, how it works. Yeah. See this. This is the what do you call lab3.c. That's what is the thing. ./a.out. So you can see it is printing the first of A is A, first of B is B epsilon, and follow of A is dollar because there is a start state dollar and no other symbol comes when you find the follow. And the follow of B will going to be A. So this is simple. We have computed the first and follow. And also we have created the parse table. You can see that. A produces A, B, A is written on the first of A. And similarly, B produces B, B is written under first of B. And B produces epsilon is written in follow of B, that is A. Okay. and it is now waiting for the input string should be given. And the important thing here is that the input string should be terminated with a dollar. Two parts. If you don't give the dollar, it will give you error. Okay, fine. I'll give the input string AA and terminated with a dollar. Okay, this is how it has passed. So it has passed step by step, starting from A. A is replaced by ABA and pop A, and go on. It goes on. So wherever the symbol is matching, it is telling it is matched, and it is a valid input. So let's see A, B, B. Sorry, one more input. A, B, B, A, and dot. Yes, yes, it's a valid string. It got accepted because we have a string starting from A having any number of B's in between and finally terminated by A. Fine. Let us go for another string, AB dollar. Okay, invalid string, because the string should start with A and end with A. In between, it can have any number of dollars. So this computation is only what we are doing it in our program. Other things we are not doing it in our program. Thus, that is parts table construction and first and follow construction. We are doing it manually and using it. Fine. That's how it works. Now let's go to the program. The program is very, very simple. Looks big with 114 lines of code, but the program logic is only few lines which you need to understand. Okay, rest of the things is only printf and scanf statements. That's it. Yeah, come to the declaration. We are declaring a two-dimensional array prod. Means that is a production of 3 rows and 10 columns. 3 rows and 10 columns, which is a string, two-dimensional string, right? Means we can accommodate 3 strings, each of the length 9 characters. That's what we mean. And we are initializing at the same time the first string, that is prod of 0. We are initializing it to first production, that is A produces A, B, A. Now let me count the characters. The number of characters is 1, that is A, and hyphen 2, a greater than symbol 3, and ABA another 3. Totally 6 characters. Similarly, here the second string is initialized to, that is prod of 1 is initialized to B produces BB. Means we have 1, 2, 3, 4, 5 characters here. And the third one, that is prod of 2 is initialized to B produces at the rate. That is 1, 2, 3, 4 characters we have. Apart from this, we are taking 2 character arrays. One is input, another one is a stack. Input is of 10 characters and stack is of 25 characters. Top is an integer which is initialized to -1. Means initially your stack will be pointing to -1. Means your stack starts growing from 0, 1, 2, 3, so on. That's how it works. Fine. And we are using 2, 3 variables, J, K, and L, usually for the loop variables wherever it is needed. Let's understand. No problem. We have the user-defined function push. What it does is it is going to push the value whatever you have supplied as a parameter onto the top of the stack. It will pre-increment the top of the stack, and to that place it is placing the value what you are giving, and it is a character. It is a character, single character. And pop, what it does is just decrements the top by 1 place, right? So it points to the previous character. That's it, right? Display, what the display does is it will display the contents of stack starting from the top. So that's why the loop is initialized to top until it reaches 0. Means after 0, the bottom of the stack will going to be your what do you call -1. So because we have initialized the base of the stack as -1, right? So until that, it will going to print all the characters in the stack. That's it. The very important function is the stack push function. This is the actual logic what is running. Yeah, stack push is actually replacing a non-terminal by its production, looking at the parts table. Right? It is replacing a non-terminal by its production, looking at the parts table. Getting the idea? So Stack push takes a character. If the given character is A, means on your top of the stack, if you have an A, with A we have only one production, that A produces ABA. So that should be replaced by ABA, correct? So for that reason, if the top of the stack is A, we should pop one character. What will be popped out? A will be popped out. In place of that, we should push rest of the production. That is your ABA is supposed to be pushed. Total length of the string is 1, 2, 3, 4, 5, 6. See the logic what we have written here. J is equal to string length of prod of 0. So we're going to get 6. 6 minus 1, you're going to get 5. Means to say, now your J will be initialized to your 5. J is equal to 5 until J is greater than or equal to 3. Initially, it is 5. Next, it becomes 4. Next, it becomes 3. So, totally 3 characters we're going to be getting. Until that, what we are doing? Push prod of 0. Prod of 0 is this. Prod of 0 of 4, 3, sorry, 5, 4, 3. That means A, B, A. These 3 characters will be pushed onto the stack. What will be popped? A will be popped. And in place of that, A, B, A will be pushed onto the stack. So A is replaced by its production whenever the top of the stack is A. Similarly, when the top of your stack is, where is it? Else. Else, pop, one character will be popped. Same logic. Now, prod of 1, instead of prod of 0, we are using prod of 1. That is your second production. Same logic here. The length of the string is 5 now. Length of the string is 5 until J greater than or equal to 3. That means 5 minus 1, you're going to get 4. 4, 3. 2 characters will be pushed onto the stack. So B will be replaced by its production in stack push. A will be replaced by its production in the stack push. Right? This is how the program is working. Right? So this is just replacement of a non-terminal by a production. Let's see the entire program now. You can see there the main program, we have one character and one integer being declared. We are using it wherever it is needed. Usually see there I is used as a loop. Right? We are just printing. The first of A is this, follow of A is this, first of B is this, follow of B is this. These and all pre-calculated values we are just printing. Fine. Next, we are supposed to construct the parse table, right? So for that reason, we are writing on the column, that is terminals, that is A, B, and $. And in the non-terminal, means in the rows, we are writing A and A's production, that is prod of 0, and B, B's production, that is prod of 2, that is B produces epsilon, which should be placed in follow of B, and B produces BB, which is supposed to be placed in first of B, that is B. So first B produces epsilon, then B produces BB. These two things we're going to be writing it, just printing the things. So this printed the first and follow set, and this set of printed statements printed your parse table. So these two things, first half task is done. Now we are supposed to go to parsing the string. That's it. So we are asking the user to enter the string, and we read it into the array. Which array? Input. Character array, which has been declared globally. You can see that is a global declaration. We have input. So we got that, and we are checking the validity of the input string. If the input is not equal to A, and if it is not equal to B, and if it is not equal to $, means your input should be a combination of A, B, and $, right? So we are printing, if this is not happening, we are printing the this invalid string. If input of I minus 1, that is the last character of your input, if it is not equal to $, then yes, we are giving and throwing an exception that string entered without a $ mark. So these two will going to check for the invalid strings. These two conditions will check for the invalid strings. If it is not that, and if we have got a valid string, then we are doing two things. What is that? Push dollar, because your in stack should be first push this dollar. And as we are implementing a top-down parser, your stack should start with a start state. In our case, our start state is A. So we push dollar first. That is a stack of 0 will be having dollar. Stack of 1 will be having A. That is our start state. Okay. Initializing I to 0, then you are printing the outline. That is the stack, input, and action, as we write down on the board, stack, input, and action, so that we can parse it. And your stack is now having your dollar and E, and your input is there in your input string. So we match the top of the stack with the top of the input, and we'll take the concerned actions. That's what is the thing we are supposed to write. Fine. Just check whether if means while I not equal to string length of inputs, I not equal to string length of input, and the stack top is not equal to dollar, then you keep on doing this particular things. You keep on doing this rest of the things. What we are doing, we are running a loop for L is equal to top of the stack, and until L greater than 0 means we haven't reached the end of the stack. What we are going to do is print a stack of L, that is A will be printed, correct? A will be printed, A and dollar will be printed. So for L is equal to L is equal to I, that is I is initialized to 0, you can see here, and L less than string length of the input, whatever the input we have given, that is until the end of the input. What we are doing, we are printing, means the stack side we printed dollar and A, in the input side we printed the input string, right? This completed the printing part. Then if the stack top is equal to A, we are printing, we are supposed to replace A by ABA, correct? No? So this we printed, and then we call the stack push function, which take the action of pushing the production of A onto your stack. Getting the idea? Pushing the production of A onto your stack, right? And then this happens when stack top is equal to A. Else if stack top is equal to B, and if the input of I, if it is not equal to B, yes, there are two possibilities for your B. One is BB and one is B produces at the rate. That is what is your epsilon. If input is not equal to B, then what we are replacing? We are replacing a B by epsilon, means non-terminal B by epsilon. And we are just telling matched, and we are removing that symbol from the stack. Which symbol? B from the stack. Else, if it is not B, small letter B, then we are calling B produces BB, yes, and we are pushing BB onto the stack. Getting the idea? We are pushing BB onto the stack. These are the only two productions we are having, so it easily can be matched, right? And if stack top is equal to input, means on input we have small b, and on the stack also we have small b, then it is a case of match. A symbol need to be removed from the stack also, and the symbol need to be removed from the input also. So that's what we are doing. Printf pop and input of I will be removed. Printf matched, and we are removing a symbol from our we are just printing here, and here we are removing the symbol from our stack. So this goes on, and the I will be incremented. Else, if there is a symbol on the top of the stack is not matching with the symbol on top of the input, then we just break from there. We go for the next symbol. That's it. Okay. And this situation, top of your stack contains dollar, and the top of your input is also containing dollar, and a dollar is always a match. Means we have consumed all the inputs, and only stack is containing no more non-terminals, and it is containing only a dollar. Then this case is called as match, and we are printing that it is a valid string and it is accepted. If this condition doesn't match at the end, we're going to print it's an invalid string. So that's how we parsed the string for the grammar. A produces ABA, and B produces BB, and B produces epsilon, right? So the most important function among them is this stack push, which is going to be pushing the appropriate production for the non-terminal A and the non-terminal B, right? So this is what is your program 3. Anyway, I'll be putting it on your group, the program. You can execute it and see, and you should be able to get the value strings and invalid strings similar to this once after the execution is completed. Fine. Okay. You can message me on your group only if at all you have any query, right? I'll unmute you all guys so that you can clarify any doubts if you have. Okay. Is it okay? All of you are able to understand? Right. If you have anything, you can write it in the chat. I got few messages. Let me check. Okay. I'll post the program on the group. You can complete execution and can see the output. Okay. This completes your program number 3. In meantime, ask your OS teacher to give you the OS programs of Ranker's algorithm, FCFS, and LRE. These things you can complete execution. Anyway, I have the program I can give you, but the explanation need to be done by your OS teacher. I'll go to those things. Okay. I'll be posting the entire manual onto the group. You can use it. Fine. Thank you. We shall end the meeting. Fine. So that's it.